All right, we're going to hit two lessons, and it really isn't going to be that much. It's really only one lesson, but it looks like two. Completing the square is what we're actually going to be doing here. When you complete the square, we're looking at making sure that we end up with a perfect square. So, for instance, if I have x plus 3 quantity squared, that's x plus 3 times x plus 3. That is x times x plus 3 plus 3 times x plus 3, x squared plus 3x plus 3x plus 9, x squared plus 6x plus 9 is a perfect square. And we've been looking at that, um, recognizing those perfect squares in previous lessons. So what we want to do is we want to complete the square. We want to say, well, what if I have x squared plus 10x plus something? How do I complete that square? How do I make it so that I can make it a perfect square? Now keep in mind the reason we want a perfect square is because I can put this in the x plus 3 squared form, which will put that in a vertex form. So we're going to practice completing the square with the ultimate goal of putting quadratic equations in vertex form. So simply put, on lesson 21, uh, somewhere 650-ish, I don't even know what page this is, but we're looking at completing the square. And you complete the square simply by taking half that middle term squared. So C in this case should be 36. Half the middle term squared. C equals 4. Half the middle term squared. C equals 25. Now keep in mind what we're doing by completing the square is creating this, x plus 6 quantity squared, x minus 2 quantity squared, x minus 5 quantity squared. So we're completing the square. We're making this a perfect square. What happens when this is a odd number? Well, C in this case then has to be 3 halves squared, right? Or 9 fourths. That means that this becomes x plus 3 halves squared. We're completing the square. Um, Lastly, let's take a look at 17. This is saying, well, in order to complete the square, right, we're taking half of that. Well, C then is uh, b over 2 squared, or C equals b squared over 4. Therefore, by having x squared plus bx plus b squared over 4, I can factor that so it says x plus b over 2 squared. Completing the square is what we're doing. Okay, let's look at it this way. When it's an equation, keep in mind this is an ugly spot here. When it's in the equation, what we want to do is create some spaces here. Half this middle term squared is 25. If I add 25 to one side of the equation, I also have to add it to the other side. I know that this is now a perfect square. It happens to be x plus 5 quantity squared equals 39 plus 25 is 64. Oh, well, wait a minute. This is now in vertex form. This is in a situation now where I could theoretically solve this. Take the square root of both sides. X plus 5 equals plus or minus 8. Subtract 5, and we got x is equal to negative 5 plus or minus 8, or x is equal to 3 and negative 13. So that's where we're headed, you guys. I went kind of quick, I know, but ultimately that's what we're doing. We're completing the square. You're going to see some different forms of this as we go, and that's okay. The textbook talks a little bit about the history. I'm not interested in this right now. We're just trying to get you to a certain point. All right, so now we're at a point where we want to use this completing the square business to be able to work with this equation in number 20, x squared minus bx plus c, and go through that process. Now, again, this is going to be a little bit detailed, but there's a reason for it. So we're starting with this, where we have x squared minus bx plus something equals, and I'm taking the c to the other side, right? And when I add to one side, I have to add to the other side. So we were treating this as if it were equal to 0, right? We're going to solve this at some level. Half the middle term squared is going to be b over 2 squared plus b over 2 squared. Now, I know by doing that, I've completed the square. I know that this becomes x minus b over 2 quantity squared. Over here, this becomes negative c plus b squared over 4. All right. We want to go ahead and take the square root. But before I take the square root, I want to rewrite this so it actually makes a little more sense. We're going to go x minus b over 2 squared equals, I'm going to put b squared over 4 minus 4c over 4. Now, all I did here, you guys, was I created a common denominator. This didn't have a denominator here, now it does, right? If I put a 4 here, I got to multiply it by 4 here. And now what I'm going to do is I'm going to go ahead and take the square root of both sides, square root, and by doing that I got x minus b over 2 equals plus or minus, and this becomes b squared minus 4 c all over 4, right? And that would actually simplify into plus or minus the square root of b squared minus 4c all over 2. And one more thing, we're going to go ahead and add plus b over 2 plus b over 2, and that gives me x is equal to b over 2 plus or minus the square root of b squared minus 4c all over 2. Now this is kind of cool because ultimately this is a formula that we're going to use down the road, or one similar to it, to solve quadratics that don't have nice numbers. But I wanted you to see the process. You're not going to have to repeat this on a test. um, but it's getting to a point where we're going to um, use something close to that. All right, a little bit more, a little bit more. All right, rewrite each expression, completing the square. Um, what we want, we're going to do this without an equal sign. So this says a squared minus 4a plus something plus 15. And now notice there's no equal sign, so this is just an expression. Half the middle term squared is going to be 4. If I add 4, I also have to subtract 4 if there's no equal sign, right? This becomes a minus 2 squared plus 11. And look at the form that it's in. It looks like it's in uh, a form for um, vertex form, right? And the vertex is 2, 11. Let's do that again. Rewrite this as n squared minus 2n plus something minus 15. Half this middle term squared is going to be 1. If I add 1 here, I'm going to subtract it here. This is now my perfect square. N minus 1 squared minus 16. Um, and hopefully this is beginning to make a little bit of sense, and you're beginning to see how the completing the square will lead to a vertex form. Trust me, we're going to do this over a couple of days. A couple more problems, and then we'll call it quits. All right, so let's work 10. 10 says y squared minus 8y plus something plus 10. Half the middle term squared, half the middle term is 4, squared is 16. If I add 16 here, I'm going to subtract it here. This is now a perfect square. Y minus 4 squared minus 6. And we're creating a vertex form. All right, take a look at 14. This is where fractions, I know people don't like fractions, but it's not as big a deal as it seems. Let's rewrite this as x squared minus 1/2 x plus something plus 3/4. Okay, half of the middle term, half of 1/2 is 1/4. 1/4 squared, right? If I add 1/4 here, I'm going to have to subtract 1/4 squared here, right? Half of 1/4 squared is 1/16. All right, this is now x minus 1/4 squared, and we'd like common denominators, right? So let's change this to 12/16. So 12 minus 1 is 11/16, and we've completed the square. All right. I know that was quick, but I think you'll get the hang of it as we go. We'll take a few more lessons on this to get through this. Good luck.